When you use the MIRAI robot control system to solve an automation task, you'll often need the tool to rotate. Our tool here is a gripper. The robot will have to turn its wrist in order to pick up this wine glass. If you want the tool to rotate for your task, you need to tell MIRAI the tool's mass and center of gravity. To supply MIRAI with that information, we configure the tool. In this video, we go over how to do that. From the main menu in the MIRAI training app, let's select Tools. The table displays all the available tools. If you haven't configured a tool yet, this table will be empty. To add a new tool, tap Set up new tool. We can do that now. Enter a name for the tool. We'll go with Test Tool. After that, select the type of robot and sensor, in our case, UR5. And on Robot Sensor. You have two options to configure a tool. One is to manually enter the physical characteristics. If you choose this option, enter the known value for the mass as well as the X, Y, and Z coordinates for the center of gravity. The second option is the measurement wizard. We recommend using the wizard to get the most accuracy. We'll focus on that for the rest of this video. So let's tap on Start Measurement Process. The first screen describes the process for measuring the center of gravity. As indicated in these illustrations, we have to move the robot to 6 different poses. We need values for plus X, Y, and Z as well as minus X, Y, and Z relative to the force torque sensor. We'll bring the tool into each of these positions and let the wizard measure the weight and position. Through the robot's native controller, we have to be able to freely move the robot. To do that, press the Free Drive button on the UR Teach pendant. If yours is an E-Series, as we have here, be sure to switch from remote control to local control on the pendant during tool configuration. It's important that you hold the arm above the force torque sensor, not below it. Don't move the robot arm by grabbing the tool. On top of that, make sure there's enough play in the cables and that everything's fit tightly in place. You don't want changing forces applied to the force torque sensor. Let's press Proceed. Now we have to prepare the robot before beginning with the measurements in each pose. The robot should be positioned with the last joint pointing straight downwards, as shown in this illustration. This is important. Once the robot is in the correct position, tap on Robot is ready. For the first pose, as shown in the illustration, take the first measurements in the starting position with the tool pointing straight downwards. Wait a few seconds so that the force torque sensor is in a static state. Tap on Measure. After the system takes the measurement, a text in green indicating measurement successful will appear. Go to Next Pose. Now let's do pose 2. Minding the cables, bring the tool in a straight horizontal position facing to the right or left. We'll go to my left. Wait a few seconds and tap the Measure button. Once the measurement is done, tap Next Pose. Now onto pose 3. As shown in the illustration, we rotate the tool 90 degrees clockwise. Then we press Measure. Next pose. Pose 4. Rotate the tool 90 degrees again. The camera will be upside down. Press Measure. Next pose. Pose 5. Again, rotate the tool 90 degrees. Measure. Next pose. Finally, pose 6. Position the robot so that the tool points straight up. Measure. Then we go to Finish. You'll see the calculated mass and center of gravity values for your tool. And we're done. We have a tool that has been properly measured with the center of gravity that's probably around here. Thanks for your time.